Hello, it's Mrs.Z. Today we are working on Exit Ticket, Grade 5, Mission 2, Lesson 26. It's Mrs.Z. All right. So, and they say estimate, then divide using the standard algorithm and check. So there is lots of work on just one problem. Okay. The first, if I do estimate, I can pretend that this is 40. Like for example, this is 45, but I'll see this. If this is 20, I'm looking compatible number that to be, so it's easy to estimate. So I'm thinking this could be 40 and then divided into 20. So how many 20s are in 40? So my answer has to be about 2, because 2 times 20 equals 40, and it seemed like how many 20s are in 45? About 2, correct? So that's one. So answer has to be about 2. Next, divide using standard algorithm. I'm going to use this way here. I'm gonna make bridge. Okay, division is a group is 21. Okay, so how many groups of 21 are in 45 and 1500s? Okay, so when I do this, I like my kids to use understanding. If I use procedure of a standard algorithm, I need to follow rules. And rule says if my number is a whole group, like group of 21, I need to make. So my decimal will appear right above where it is in my problem. Okay, but also I'm gonna go one place value at a time. So I'm going to use my sticker, which I like to use just to focus on one number at a time. So I am also putting those lines up so you cannot miss the place value. So if I have 4, I cannot make a group of 21. I can make 0 groups. So now if I move and I change 4 tens for ones, I will have 45 ones. So if I have 45, can I make a group of 21? Yes, I can. So there are 2 groups of 21 in a 45. So now, what is 2 times 21? 2 groups of 21 is really 42. If you are not sure with multiplication, it's so simple. If you just say, okay, if this is one group, that's 21, I can add one more group that will 42. So 2 groups of 21 are 42. So not 45. So I needed to subtract 42 from 45 to find that I will have still $3 extra. Okay, so now I am done with 4, then with 5. Now my next is the tens. I'm going to bring down the tens. And now when I have $3 in 1/10, altogether they become 31/10. And my answer has to appear right here. So the question is, how many groups of 21 are in 31? There is only one group. And you can see here, you don't have, if you have 2 groups, then you need 42. You only have 31, so it's 1. 1 times 21 is 21. When you subtract, you're going to get 10 dimes extra, or 10 tenths extra left over. Okay, that's a remainder. The then you're going to go and do the last number. Make sure that you put your arrow down, because when you bring down the number, you have to work it out. You have to ask yourself the same rule. How many 21s are in 105? And then you can skip count, thinking this is 20, correct? So 20, 40, 60, 80, 100. So that's 5. 20, 40, 60, 80, 100. So my answer has to be 5, because 5 times 21 should get 105. But let's check if it's that true. You can keep adding here till you reach 105, and you will see if this number is good guess. So 42, if I add 21 again, that will be 3 groups, and that will 63. I will add 21, and that will be 4 groups, and that is 84. And I will add 21. That will be 5 groups of 21, will give me plus 1 here, and that is 105. So now we have proof that 5 times 20 is 105. So our 5 is correct. 5 times 25 is really 105. And then I have no leftover, so my answer is 2 wholes and 1500s. So the real answer on this problem, that is 45 and 1500s divided into 21 group. Each group will have a 2 and 1500s. So now we have to check, because we did estimate that's 2. We did divide a standard algorithm, and that is 2 and 1500s. And then we need now to check. So if your operation is division, you check with multiplication. So if this is division, you're going to check with multiplication. So you can see this way how you can, if you do multiplication, then you check with the division. It's a fact family. So what you need to do is our answer times 21 must equal this number. So if you see this, so 2 and 2, I can think this as a 200 and 1500s, if you like that way. Hundreds, THS, hundreds, times 21 must equal 45 and 1500s. Okay, so let's check. So 1 times 5 is 5. 1 times 1 is 1. 1 times 2 is 2. Or 1 times 215 is 215. That's what really we are working. We said 101 times this number is the same number. Okay, now this number is 20, so I'm going to put 0 from the 20 here. And then I will go the same thing. 2 times 5 is 10. Or 20 times 5 is 100, but I made 2 times 5 is 10, so I need to add one more. 2 times 1 is 2, plus 1 is 3. And then 2 times 2 is 4. Okay, let's underline and add. Going to use my place value highlighters. 5 plus 0 is 5. 1 plus 0 is 1. 2 plus 3 is 5. And 4 plus, I can put 0 here if I want to. So that is 4,515, but they're hundreds. Okay, hundreds. So when I have this many hundreds, I have to show my, if I want to change that into whole numbers, it is, you should show hundreds. So 45 and 15 hundreds. And that is correct answer. So now we check our answer is correct. 45 and 1500s divided into 21 groups. Each group will get 2 wholes and 1500s. When you multiply 215 by 21, you will get 45 and 1500s. You can think as $2.15 as 215 pennies times 21 will give you 4,515, but what? Pennies or hundreds. Now you change those pennies into the dollars and they become $45.15 pennies, or this 4,515 hundreds will become 45 wholes and 15 hundreds extra. Sounds good? All right, let's move on to the next one. Okay, so now I'm going to do 14 and 95 divided into the 65. I'm thinking 65 is about 70, so 7 and 14 are connected. So I can really think about this to be 14 divided into 70. That's my estimate. So if I think 14 divided by 70, I can use that strategy. Remember, 14 divided by 7, and then again that quotient divide by 10, because 70 is 7 times 10. So let's see, this could be 14 divided by 7, and again divide by 10. So 14 divided by 7 is 2, because 2 times 7 is 14. And then 2 divided into 10, when you divide $2 into 10 pieces, each piece is a 1/10. So the 2 will get 10 times smaller and it becomes tens. You can, if you like, you can put decimal right there and you will see that the place value changes from $2 to 0 and 2/10. So my estimate is 0 and 2/10. Okay, for this problem. But then they say to the standard algorithm. So let's do that. All right, I'm going to use this here. Make bracket. Let's make nice big numbers. 1, 4, decimal point, 9, 5. I'm going to extend. I love my triangular rulers because they're really good tools to work with precision. Okay, so my group is 65. And then my decimal is right here in so I'm gonna appear right there in my answer. I'm going to draw a line with my highlighter. And I'm gonna go one number at a time. If I have a 10, can I make groups of 65? No. Okay, if I have a 14, can I make groups of 65? No. Can't. I make 0 groups. But if I have 149, if I think about this all 149, I can make groups of 65. So you can round. 1660 is 120, so you can guess that has to be 2 groups there. So 60 plus 60 is 120, and you have 140. So it should be here 2 2 times 65. If you like to do that, you can say 2 times 5 is 10. So that's 0. I remember 1, 10. Okay. And 2 times 6 is 12 plus 2 times 6 is 12 plus 1 is 13. So that will be how much is. So now you can subtract. 9 minus 0 is 9. 4 minus 3 is 1. And 1 minus, so there is 19 leftovers or remainders. But we're not done yet because we need to bring down the last number. But before that, we're going to check, did we guess correctly? Because sometimes we are not good in guessing. So if I say 65, that's one group. And if I add one more, that's 2. So 5 plus 5 is 10. Remember 1. And 6 plus 6 is 12, plus 1 is 13. So it's really 130. So we did good in the estimation. So 2 times 65 is 130. Here, minus 130 will remain the 19. Now we have one more number. That's 5. So what that really means is you're going to now change $1, 9 dimes, and 5 hundreds into 195 hundredths. So now how many groups of 65 are in 195? You can also guess, keep adding by this 60 plus 60 is 120 plus 60 is what? 3 times 6 is 18. It should be 118, correct? So 180, sorry. So, but then it's good to go with this. Continue. You are adding groups of 65. So now this would be 195. And how many groups are there? Is 6 times 65 times 3 is 195, which is perfect number. If you didn't do this, you can guess, okay, I said you round this to 60 and then you get to 180. And then you say, okay, I did 3 groups. 3 times 6 is 180. So I need also do 3 5s. 3 times 5 is 15. And then 180 and 15 is 195. But let's see. So our guess is 3. 3 times 5 is 15. I remember 1. 3 times 6 is 18, plus 1 is 19. And that is perfect. And you can, or you just go here and you say, okay, there are 3 groups of 65, and 3 times 65 is 195, and you subtract, you got your answer. So real answer is 0 and 23 hundredths. On this problem, the real answer is, I'm going to rewrite problem 14 and 95 divided by 65 is equal to 0 and 23 hundredths. Our guess was 0.2 or 0.20. So we were close. 20 hundredths, and real answer is 23 hundredths. Now we need to check. Remember, when we have division as a problem, our check is multiplication. So what that means is 0 and 23 hundredths times 65 must equal 14 and 95. That is what it should be. So now let's see if that's true. Is it 65 times 0 and 23 hundredths equals? So I'm just going to do 65 times 23. So we're going to use standard algorithm. 3 times 5 is 15. 3 times 6 is 18 plus 1. So here is the 3 times 5 is 15. Remember 1. 3 times 6 is 18 plus 1 is 19. We're done with ones. 3 times 65 is 195. And then you're going to put 0 for 20. 2 times 5 is 10. Remember 1. 2 times 6 is 12. Plus 1 is 13. So now you can add these together. 5 plus 0 is 5. 9 plus 0 is 9. 3 plus 1 is 4. And 1. That is 1,495. But where are these 23 hundreds? So when they are hundreds, then we have to change the hundreds into standard number, which is 14 and 95 hundredths. 14 wholes and 95 hundredths. So that's true. This here is when you multiply it, 14 and 95 hundredths, and that is the same as other side, and that is the true equation. Okay, guys, so that was B for exit ticket, grade 5 mission 2 lesson 26. This was B. All right, I need you to see all. Now I can see all. I'm trying to make sure that you can see all of them. So make it smaller. And that was the A and the B. All right. This was Mrs. Z, and have a good day. Bye, guys.